Hello, this is Ron. I'm in my basement and I'm tracking down a thief. Let's find him. Over in this corner of my basement, it's my little workspace, I have a rack of computers and audio equipment over here, and more audio equipment over here. I used to have a little recording studio down here, and of course we all know that wall warts, like this one here, steal energy from you even when they're not in use. If you leave them plugged into the wall, they continue to suck energy and cost you about 50 cents a year for each one of these wall warts. And that depends on a lot of conditions, but so yeah, I keep my audio equipment isolated. That is, I unplug all my wall warts, and the whole rack is unplugged most of the time right from the wall. But this guy, the computer, I never think of the computer because I don't have any wall warts plugged in. But I was checking anyway while I was cleaning up a little bit, and I have a kilowatt meter here, and there's almost 8 watts of power on being sucked out of my wall, even though all my devices at the moment are turned off. There's nothing on at the moment. And as you can see, I have another wall wart down here. I have it unplugged unless I'm using it, but I do leave the power on for the computer. I don't really think much of it. So let me put you down on a tripod and I'm going to find out who's sucking the power out of my wall. Okay, the first thing I want to check is just some different types of wall warts before I go looking for that little thief. I have here a gigantic wall wart. This is a 1 amp wall wart. And not being plugged into anything, just being plugged into the wall. The other end is not actually driving any equipment. Looks like it's pulling about 2 watts. Just doing nothing. If I left it plugged in, that would be 2 watts right there. Let's try another type. This is a special smart charger. Now this one is really light. The other charger I held in my hand was about 3 pounds. This guy, hardly an ounce. This case must be empty. It's probably just full of Schottky diodes and maybe a capacitor or two. So let me plug this newer type in. 0. I can leave this one plugged in because it's a smart device. It's not drawing any energy unless it's actually charging a battery. This one's good. I can leave it plugged in. Let's move on. This is a regular everyday wall wart. It's very low power, only 300 milliamps, which most of them are. Again, it's not connected to anything. Plug it in. Okay, powering nothing. 1.26 watts. Now, that's not much power, and it doesn't cost much money. But when I'm done with this, we're going to add this up. I mean, in my basement alone, I have, gosh, maybe 10 of these things. They're on printers, they're on audio systems, they're on TV monitors, flat screens, power supplies for phantom powered microphones. I mean, they're on everything. So how many do you have in the house, and how many are sucking power? Okay, I'm going to turn this off just for a second. I got to shift a little bit. Hold on. Okay, I've got 4 more plugs down here. Let me pull a plug and take a look. This one's my printer. Very good. My printer is not using any power. I should say stealing any power. No phantom power there. Let's see, this one's going up. I don't know where that is from. Okay. Somebody's using half a watt right here. Let me trace that wire for a second. Hold on. That is my LCD flat screen. My power saving flat screen is using half a watt, just sitting around doing nothing. Well, thanks a lot for that. Let me check this guy out. I think this is the computer itself. Yeah, it sparked when I plugged it in. It's like, holy moly. Kidding me? Okay, the computer's using 7.3 watts, even though it's turned off. So, that's quite a bit. 7.2, 7.3, alright. Alright, Mr. Computer. I thought he had a battery in him to keep his clock going. Why does he have to keep sucking energy? And this thing. I think this is my old-fashioned stereo here. It sucks no phantom energy. That's because back in the 80s when I bought this, no such thing as phantom power loss. It's a modern invention. Thank you. Alright, the topic is phantom power loss. And the first thing I want to explain is I base this on the cost of a kilowatt hour of electricity at 8 cents. And that's because in Rochester, New York, that's what I pay. And arguably, I probably have the cheapest electric service in the country. We're very close to Niagara Falls, where Tesla designed the first major power station that's still in operation today. And we're only 20 miles from a nuclear facility that provides a tremendous output. So let me begin here by just hiding some of this. I made a giant spreadsheet. You don't need to see all the calculations here. You don't need to see hours per year and all that. And let me just hide that. Now, okay, how many of you people have a wall wart or two plugged in? How about an LCD monitor for your computer? How about the computer itself? How about a powered TV antenna? How much power is your TV sucking up when it's turned off? Got a DVD player? Maybe a GX sweeper, one of those little sweeper machines from the internet? Like the info ads on TV? Answering machine? Maybe you got a noise machine for the bedroom, the wave machine. Make some noise, sleep better? How about the clock in your bedroom? How about the docking stations for phones and laptops? How about a second computer, your modem? How about your microwave and stove? They both have clocks in them. What kind of energy are they sucking up? Well, they're all sucking up something, even when they're turned all the way off. Like when your docking station is doing nothing, but you left it plugged in, it's still sucking up energy. My paper shredder, for God's sakes, almost a constant watt of energy so that a glowing LED can tell me it's plugged into the wall. And of course our TVs that never turn off. Even when you turn them off, they're not off. So let's look over here at the dollars per year at 8 cents a kilowatt hour. So your wall warts cost about $1 a piece a year if you leave them plugged in. That's not much money. You know, you could say, you know, it's only, gosh, that's not even a penny a day, Ron. That's infinitesimal. Well, let's start adding this crap up, shall we? LCD monitor. Now, your monitor has a standby state. I'm not talking about the standby state. I'm talking about when it's completely off. When there's no glow on the button at all. It's not blue for on, it's not amber for standby. It's off. It's still, since it's plugged in, it's costing you 35 cents a year to leave it plugged in. That's ridiculous. My computer sucks up an astounding 7¼ watts when it's not on. That's ridiculous. Since there's a built-in battery for the clock, why does it need to hover at 7 watts in case I push the button? It's ridiculous. That's ridiculous. Now I have a powered TV antenna. I'm going to leave that on. My TV tuner is ridiculous. I got to junk that piece of crap and get something new. Because even when it's off, it's actually on and sucking up an astounding 15.5 watts every second that it's on. And that's on 24 hours a day. You think it's turned off, but it's still running. There is no off for the DVD-R. And the list goes on and on and on. How many people have an answering machine? You probably got an answering machine. Probably costs you about $250 a year. Just leave it plugged in. Your bedroom clock. You know, everything. Well, you add it all up. All that stuff comes up to an astounding $49. So I get a little closer. $49.75. And that's probably giving you too many lines there. $49.79 at 8 cents a kilowatt hour. How much are you paying for electricity? Now some of this stuff is necessary and I'll leave it on. My fax machine is beyond for real estate business, and the modem will stay on for convenience where we can use our, you know, laptop devices and such. But the paper shredder? Are you kidding me? That's ridiculous. Ridiculous. All these things use phantom power. That is, they never, ever, ever turn off. That's ridiculous. And computers are not created equal. My computer is fairly modern, and it cost me $5 a year to leave it plugged in. Now, I'm definitely getting an on-off switch for that. As opposed to Roberta's computer, only cost $2.21. Her computer is using half the power. Standby power. I should not standby. We're not talking standby. Phantom power, just being plugged into the wall. Hers is an older computer, and it's using less energy. Now, why is mine using twice as much? I don't know. The computers are almost identical. I mean, the same kind of speed, RAM, the works. The only difference is the modern power supply, like all these other devices, are constantly chewing up energy. And I can't help but think it's not for my convenience. It doesn't turn on any faster. I have no idea why modern manufacturers are making all these devices that don't actually turn off. There's no remote control for the computer. It's not waiting to be turned on by remote. I mean, what the heck? Well, I'm frankly appalled, and I'll be making some changes. And we've been talking about phantom power loss. Do yourself a favor, buy a kilowatt meter. Kilowatt. Look it up on the internet. They're fairly inexpensive, and you can check not only how much phantom power you're losing, but how much it costs to run your refrigerator for a year. It'll do the calculations for you. You don't have to do it the way I did. So, this is Ron. Look for phantom power and turn it off. You don't need to give your money away to the power company. See ya.